Hello friends, this is Durga again from Technology Mentor / ITversity, and as part of developing applications using MapReduce API, so far we have seen the introduction and then brief introduction of HDFS itself. Now we will be seeing a brief introduction about MapReduce. So MapReduce, typically developers develop a class called mapper class, which means either they will extend or implement interfaces related to mapper, and then reducer class, which means they extend a class called reducer or implement interface called related to reducer. This will be the predominant development using MapReduce APIs. On top of that, when we want to develop a application using MapReduce, we have to develop many complementary classes like parsers to ensure the data quality and all those things, which is typical in any Java application. And on top of that, there is something called shuffle and sort in the process, which we will see in detail later. And as part of the shuffle and sort, you can tweak the existing logic to change the behavior of that. And all those things we will see later. And also, when it comes to API, there is both the old API as well as new API with respect to MapReduce. And old API is being decommissioned, so any new projects you should not use old API. Instead, you should use new API. And also, you cannot mix and match old API and new API. You will run into issues. So, if old API is being used for existing development, you have to continue enhancing that using old API, or you have to re-engineer and redevelop everything from old API to new API, or you have to develop using new API only for all the new applications. So that being said, as we have seen yesterday, you can go to Google and search for Hadoop API, and you will get the latest one. Click on this, and we have seen three categories: common, MapReduce, and yarn. When we talk about MapReduce API, it's predominantly the second category, which is MapReduce here, and the package MapRed under org Apache Hadoop is old API, and the package MapReduce under org Apache Hadoop is new API. There will be so much similarities between the class names, and the purpose of new API is to improvise on the readability and also to fix certain issues that are there in old API. And new API is much better organized than old API, and we will be using new API to develop our programs. That being said, let me whiteboard about the logic of MapReduce to begin with, and then we will quickly develop a program starting from default programs to row count, and we will slowly get into the more complex programs. So for this whiteboarding, I will take the example of row count, which is very simple, and I will explain. So as we have seen, our file is divided into three blocks. Large deck, which is 350 MB, is divided into three blocks when it is stored in HDFS, and the map logic should be relying on the fact of this. First, let me explain what will happen when we try to run the application than the development of application itself. So when we actually try to run the application for row count, so what will happen is we have three blocks for the file. So the three blocks have many records, and the first block have R1 to R so on, and then second block have Rn to so on, and the third block have Rz to so on, or Rz to so on. So when we try to apply the row count logic on this, which we will be developing, so we have to develop two tasks, map and reduce. And that will have the logic of counting these things. We need to leverage both the things to get that implemented. But first, let us see what is the how it will be executed. So we need to develop map class and reduce class, and it will be executed as map task and reduce task when the job is submitted. So what this map task will do is, map task is nothing but a JVM, and our logic will be executed in that. And what it will do is, it will read this data which is in the block, which is in this block, and typically wherever this block is, only there this map task will execute, and it will read one record at a time from this block, and it will do the necessary, it will execute the necessary logic that is developed in the mapper. Similarly, there will be another map task, another JVM, and this will read the data from block 2, and then it will apply the logic that is developed as part of the map class which we will be developing. Similarly, another JVM, and it will take care of this block. And after these three have completed, there will be another task called reducer. It can be on any of the nodes in the cluster, and it will take the output from these JVMs, and then there will be logic in the and the logic that is there in the reducer task, reducer class, will be executed as part of the reduce task, and it is under JVM. So what will this logic should contain? So in map, actually, apart from the logic which you will be writing, the framework itself will provide some logic. That logic is to read the file or each of the block by this JVM created for the mapper, and emit the output from this mapper to something called intermediate files, and those intermediate files will go through a process called shuffle and sort, which we will see later. And after shuffle and sort process that data, that will be modified, means that will be actually modify the output of the mapper in such a way that reducer can actually do the stuff like aggregation, joins, etc. So in this case, we just need to do the row count. So for each record, what map logic will contain is, it will actually apply the transformation. If we want to do the filtering, we can do the filtering as part of the map logic or even before. But in this case, there is no filtering for row count. We want to get the count of all the records, record count. For each record, the map function will be applied. The map function is the one which we will be developing, and in that we need to take care of transformation of these records in such a way that eventually they can be counted in reducer. So in this case, the transformation should be from this row, it should translate into a common key across all the records, for example count, and then 1. For each record, we have to apply the transformation as part of the mapper logic. And similarly the case with all the blocks, with all the JVMs, for each and every record we will do this transformation. And this is called as tuple, and it has key and value for in this key. So in these tuples, the key is count and the value is 1, because we have to add those things as part of the reducer. So once the count is once the output is emitted to from the mapper, it will go to the shuffle and sort phase, the entire data set. As we have only one key, what will happen is this all these tuples will be grouped on this on each and every key. In this case, we have only one key, which is count. If we have multiple keys, there will be multiple groupings happening. In this case, as we have only one group will be formed, and it will look like this. It will also a tuple, and it will have the unique key, only one key, and then array of values. Okay, and this will be passed as input to the reducer task, and for each unique key, the reduce function will be invoked, which will be developing, and that reduce function should have the logic of aggregating this to get the sum. In this case, we just need to add all these values and we will get the final count, and that count will be returned to another block or file, count file, let's say, and it will have the one block. Let's say it is B4 because block IDs are unique, and that will have the final count in HDFS. This is nothing but HDFS. So this is the typical life cycle of a simple MapReduce row count application. And as we have seen, the main things which you need to understand is there is a map logic that needs to be implemented. There is a reduce logic that needs to be implemented even for a simple program called row count. And we will see those, how to develop those map functions, reduce functions to begin with, and then we will see a lot more details as we proceed. So as part of the APIs, to implement a map function, to implement the map logic, you need to extend a class called mapper, and to implement the reduce function of reducer classic, you need to implement or extend a class called reducer. So here we will go to the MapReduce APIs again, and in this for the new API there is a package called MapReduce, and you can click on that, and then there are a bunch of classes in them, but at this time we are interested in mapper class. So it looks like this. Mapper takes these 4 parameters. The class can be can take a key in and value in, key out and value out, which are called as types in MapReduce APIs. And similarly, reducer also takes key in, value in, key out, value out. So these two are the classes which we need to extend to implement our map logic and reduce logic of any MapReduce application. And if you click on these classes, there are subclasses to them, and these subclasses will actually provide some predefined functionality in them. We will see those things to begin with, and by default mapper also have the logic of behaving in certain manner. So even though you do not extend mapper and just run MapReduce program using the class mapper and class reducer, there is a predefined functionality in them, and we will see that, and we will try to run a program in a moment about how it will look like. So now we will be developing the first MapReduce application, and we will be using the default mapper class and reducer class, and also we will see some predefined mappers and reducers, and then we will try to use them in our application of row count, and then we will develop the advanced programs. So to develop, I will highly recommend Spring Tool Suite, which is a Java Eclipse based IDE, and it is pretty decent, and also we need to have Maven plugins. So we will create a new Maven project here, and we will give the location. I don't want to create in the default workspace. I will give a new location. So this new location directory should not be there. So whatever location you mention here, that directory should not be there. You have to give whatever location you want, but not the existing one. And in this case, this is the location I want to use. I will be developing New York Stock Exchange based MapReduce application. So I am naming it as NYSE, and click on next. But for some use cases, I will try to show the deck of cards example while demonstrating. But for the main application, it will be New York Stock Exchange data. In this case, group ID, you can give like COM, and artifact ID and YSC, and then you can click on finish, and it will generate a MapReduce application. Sorry, it will generate a simple Java application, and we want to make it a MapReduce based one. So the first thing you need to do is you have to define your pom.xml to download the binaries that are required to compile your programs. So for that, you have to create the dependencies. And under this, first we will create dependency for common, and it has artifact ID and group ID, artifact ID, and version. So you don't need to do it manually. We will avoid that in future, but I want to explain you the life cycle, so that's why I'm doing it manually. So for group ID, it should be org.apache.hadoop, and then for artifact ID, we need to get the underlying jar file names. So for that, I have a 2.7.1 binaries installed on my laptop. So here I have if you see, I am in something called so this Hadoop is nothing but Hadoop 2.7.1, and if you just install in local mode, then it will have this layout. Under the home directory, you will have bin, and then another directory called share, and under that you have to navigate through the directories, and there is another directory called Hadoop. So this one will have all the jar files, and common will have the common jar files, as we jar files for all our common AP common packages, which are represented here. And then MapReduce will have all the jar files related to MapReduce APIs, which are represented here. So we need to have at least the common jar and the MapReduce core jar. So we will add those dependencies in a moment. So you can actually go to common and then ls-ltr, and we want to get these jars defined as dependencies as part of the MapReduce application which we will be developing. So artifact ID will be Hadoop common, and version is 2.7.1. And also we want to have the MapReduce related jars also, and in this we want to have the core. If you want to understand why we are doing core, you can run jar tvf and Hadoop MapReduce client core and more. You can see bunch of classes, and it has the MapReduce related classes in this. And especially if we scroll down further, you can see that our mapper and reducer classes are part of core. So we need to have the dependencies for these two. So let's go back to Eclipse or STS and create another dependency for MapReduce core, which is, so this one will be the artifact ID, and then this one will be the version. Like that, you should determine the dependencies. So version is same, only I have to change the artifact ID, and you can save it, and then it will build the workspace and it will download the required jar files. You can see those here, all the jar files, which, and also their dependencies will be automatically downloaded. Okay. So even though we have defined only two, it would have downloaded many other jar files, because these will be depending on others, and the POM files related to these will have those dependencies. So Maven is capable of understanding those things and download all the dependencies for us. So that being said, we kickstarted a simple MapReduce application. We will be developing that as part of the next video, but so far we have um, uh, tried to define Maven plug sorry try to define dependencies in the POM file for our basic MapReduce program, which will be using mapper default mapper class and default reducer class to see the functionality of that, because it is very important to understand what happens by default as part of the mapper class and reducer class, and we will see how we can extend those things and what kinds of logic and how we should implement as we move forward. That being said, I hope you are enjoying the content so far on my channel. If you have not subscribed yet, please do so. You will learn a lot more content than just Hadoop or big data, not only from the development perspective but also from administration perspective. And if you like a particular video, please click on the like button. If you want to post any question or comment, please use the comment section of the respective video. Thank you. Bye.